Hello guys, so we're starting 4.8, which is indirect measurement. So let's define a few things. Okay, so for indirect measurement, uses the properties of similar triangles to find measurements that are difficult to measure directly. So it's when it is difficult to measure directly, we use the properties of similar triangles. One type of indirect measurement involves shadows. Okay, so for instance, since it's similar triangles, that means we can set up a proportion. The way we think about our proportion doesn't always have to be this way, but if you set up this pattern, it'll help you. Always do the height over the shadow. And remember, what's on the same on one side on top must be the same on the other side on top. The same goes for the bottom. So here we go. So a flagpole casts a 32-foot shadow at the same time that Evan casts a 9-foot shadow. If Evan is 6 feet tall, how tall is the flagpole? Okay, so when I'm looking at this proportion, I'm going to set up where I have the ratio of height over shadow, but I'm going to have the flag equal to Evan. Okay, so I'm going to have the flag is the shadow for the flag is 32, so that's going to go on the bottom. And then it wants me to find out how tall the flagpole is, so that's going to be X. So therefore, we would let X equal height of flagpole. Okay, make sure you can read what I'm writing. Equals, now we talk about Evan. So it says that Evan's shadow was 9 feet and his height is 6. So now I have my proportion and we can solve. So we multiply diagonally, use the little butterfly method, and we end up with 9x equals 32 times 6, which is 192. Divide by 9, and yes, you do get to use a calculator. And x equals 21.3 repeating feet. This could also be written as the fraction of 21, oops, no decimal, 21 1/3 feet. Both of these are acceptable answers. And notice in this instance, I included the units. Word problem, you got to have the units to talk about. Okay, moving right along, turn to the next page, and we are going to work number 7. So if we're looking at number 7, put this to where we can see it well. It says the Arc de Triomphe in France is, so the arc is 160 feet tall. If the arc cast, so the arc's shadow cast is 98 and 2/5 feet tall. At the same time, a nearby street lamp has a shadow that is 9 feet long. We want to know how tall is the street lamp. So the first thing I'm going to do is let X equal height of street lamp. Now, I can use, I've got a fraction in here. I can leave it as the fraction, or I can realize and change this to a decimal. I'm going to look at the 2/5. Well, 2/5 is the same as 4/10, which is 0.4. So therefore, this could be written as 98.4 feet tall. Okay, so again, we're doing height over shadow. So I'm going to do the arc is equal to the lamp. Okay, so I've got that it's 164 feet tall over 98.4 4 is equal to, we don't know how tall the street lamp is, so that's going to be x over 9. And now I've got a proportion, so I solve my proportion. We multiply diagonally, and we end up with 98.4x equals, excuse me, 1476 feet. We divide by 98.4. It cancels, and we end up with x equals 15 feet. That's how tall the street lamp is. Okay, jumping down to a little bit different type of problem. All right, so let's look at number 9. Okay, this is used quite often. We use the shadows for measurement, but surveyors, which is done in your architecture, landscape architecture, civil engineering, construction of anything, you have surveyors. They also use similar triangles to find distances that do not involve shadows. So that means you don't have a shadow to use. So given the diagrams, find each missing measure, round to the nearest 10th when necessary. So you got to pay attention to what it's telling you to round to. Okay, so it tells me that the triangles below are similar. Find x, the distance across the river. All right, well, I've got to think about the fact that this triangle almost has to be rotated around so that I can make sure that my corresponding sides are correct. So I may want to redraw this triangle that's upside down so it matches. So there's my right angle. So therefore, this is 15, and this up and down is 82.5. You don't have to redraw. It's entirely up to you. All right, so I'm looking for the missing measure. All right, so this is similar figures right here. So I'm going to have, I can do the x goes with the 24. So I put the, in a sense, I'm comparing here the height over the base. Let me make that a lowercase h. Height over base equals 82.5 over 15. This is not the only proportion that can be written. Okay, you could also write it with 82.5 over x and 15 over 24. There are multiple ways, but either way, you will get the same answer. Okay, so now we multiply diagonally, and we end up with 15x equals 82.5 times 24, which is 1980. Divide by 15, and we get that x equals 132 feet. And that is the height, or the actual width of the river. That's the width of the river. Okay, you will finish the notes problems and the homework problem in class. Have a great day. Bye.